Hey guys, welcome back. Today we'll have our fifth problem.
This problem is called longest palindromic substring. Given a string S, find the longest palindromic substring in S. You may assume that the maximum length of S is 1,000. If the given string is BABAD, the output can be BAB or ABA. If the input string is CBBD, and the output should just be BB. Okay, let's look at the code. I use C++ again here. The function has only one input, the string S. This is kind of a brute force method, so we need to recall the current max length. And we also need the start position of the palindromic substring. For simplicity, we assign the length of string S to an integer n. When n is less than or equal to 1, the string is either an empty string or a string with just one single character, so we just return S. I iterate through every character in the string, not as the start of the palindromic substring, but as the center of the palindromic substring. We also have a variant j here. Imagine two pointers pointing at I here. When j increases by 1, the left pointer moves to the left by 1, and the right pointer moves to the right by 1. There are two types of palindromic substrings. The first type has odd length, for example BAB or ABA or CBABC, while the other type has even length, such as ABBA. We consider the first type here. Given I and j, the substring is located between I minus j and I plus j included. Therefore, I minus j must be greater than minus 1 and I plus j must be smaller than n. J should be smaller than n minus I and I plus 1. Starting from 0, we increase j by 1 every time. When j is 0, Si must be the same as Si. Every time we check whether Si minus j is the same as Si plus j. If so, the substring is still palindromic. The length of the substring is 2j plus 1. If the length is greater than the recorded max length, we update the max length and the starting position of the substring. If Si minus j is not the same as Si plus j, the substring is not palindromic, then we just break the loop. Okay, now we come to the second type of palindromic substring. Let's take a look at ABBA. To satisfy this condition, the middle of the substring must be two successive identical characters. So Si must equal to Si plus 1, and that's also why I must be smaller than n minus 1. So here the substring is located between I minus j and I plus 1 plus j. And its length is 2j plus 2. Likewise, if the substring is still palindromic and the length is greater than max length, we update the max length and the max start. The return type is a string, so we use the substring built-in function. The two arguments, starting position is just max start, and the length is just max length. The runtime is 8 milliseconds, and it beats 97%. If you like this video or if you find it useful, please subscribe and see you next time.